The fast-growing field of nanotechnology has gained much attention in recent years. Nanotechnology is manipulation of matter in the fabrication of devices on the atomic scale. Nanomaterial, or nanoparticles, have a size range of 1 to 100 nanometers. Remember that 1,000 nanometers equals 1 micron. This table of common particles and contaminants illustrates the microscopic size of nanoparticles. In more general terms, a nanoparticle is to a soccer ball as a soccer ball is to Earth. Nanotechnology research is an important component of many scientific fields. One of the fastest developing uses of nanoparticles is as a drug delivery system. Nanoparticles can be administered intravenously where they easily float through the bloodstream seeking cancer cells. The particles selectively bind the tumor and send signals indicating their precise location. Doctors can then more accurately visualize a tumor that would not register on a conventional medical scan. This is just one of hundreds of ways that nanoparticles are being used today. As nanotechnology is becoming increasingly prevalent, it is likely that you will have some interaction with nanoparticles in the laboratory. As such, it is important to understand the risks associated with their use. Nanoparticles present two possible dangers. First, environmental. Due to their high surface-to-volume ratio, nanoparticles are very reactive and catalytic. Second, their microscopic size allows them to easily penetrate cell membranes, having a toxic effect on tissues and body systems. This image illustrates the various methods of entry and diseases associated with nanoparticle exposure. Working safely with nanomaterial requires the strict adherence to standard procedures in order to prevent inhalation, skin contact, and ingestion. This can be achieved in 3 simple steps. Number 1. Implementing specific engineering controls. This is achieved by working with nanomaterial in a liquid media during pouring or agitation, which could release aerosols, or when fabricating nanoparticles and cleaning equipment used to produce them. Number 2. Observing safe work practices. Examples of this include storage of food and drink where nanomaterial is handled, washing hands, thoroughly cleaning the workspace, and accurately labeling containers in which nanoparticles are stored. Third, properly wearing personal protective equipment. Although there are currently no universally accepted guidelines on the selection of personal protective equipment while working with nanomaterial, wearing gloves, lab coats, goggles, and masks will greatly reduce the risk of overexposure. This list represents simple guidelines that serve to protect from the damaging effects of this material. Nanotechnology is an exciting, rapidly developing field comprising hundreds of applications. Whether you're pursuing a degree in medicine, chemistry, physics, or engineering, you will undoubtedly encounter nanomaterial in the laboratory. Adherence to the 3 steps outlined above will ensure a safe working environment and prevent health problems related to overexposure.